Now, this may be a new for you, but it is my expectation that given a formula, you have to correctly identify whether it is true or false. If you say that a formula is false when it is actually true, it won't be possible to earn points. And if you say that a formula is true when it's actually false, it's not possible to earn points. Now, let's clarify some expectations even further. If a formula is in fact true, if it's indeed true, you must give valid reasoning for why the formula is true, and these valid reasonings need to be based on the class standard. So we will talk about what is considered acceptable as an explanation for why a formula is true. Likewise, if a formula is false, you have to give valid reasoning based on the class standards for why the formula is false. These are very daunting tasks at first, and they'll take a little getting used to, but it will really set up a foundation for everything we do. So, the first thing to ask is, well, how do we do these tests? How do we identify whether a formula is true or false? And then, how do we argue that a true formula really is true? And how do we go about arguing why a false formula is false? Let's start by talking about how to show that a formula is false because that's the easier task. So how to show a formula is false? This will always be the case throughout the semester. For each variable you see in the formula, you must select a number. Just select a number, then simplify the left side using the order of operations. Don't use the formula in question. We'll make more sense of that in just a moment. Simplify the right side using the order of operations. Again, don't use the formula in question. You must select numbers which allow for completely simplifying each side without a calculator. That is really key for reasons I won't dig into right now. And then you have to select the numbers that you select in the first place, up in step one. You must select numbers which result in the left side and the right side being not equal. You end up at the very end, the left side simplifies to a number and the right side simplifies to a different number. So let's take a look at this formula, which was already mentioned as being false. But why is this false? I mean, it just seems like this exponent n ought to be able to distribute like as shown here, but apparently that's not allowed. So why should we not trust this formula? Right? So first of all, even the way the question is worded, the question isn't trying to give anything away. So we first have to identify whether it is true or false. So this one, I want you to start to recognize that this is a false formula. That when you see an exponent out here and a plus sign on the inside, it is not a thing. It's not, we're not allowed to distribute the exponent here. So we'll identify first of all this is false, and then go through that process of showing a formula is false. We just need for all three variables, that is x, y, and n, we just need to pick numbers. The numbers need to work out in some sense, which we'll see in just a moment. So just kind of bear with me here as I picked these numbers. I let everywhere there's an x, we're going to substitute or plug in or replace, whichever of those words you like, a 1. And everywhere there's a y, we're going to substitute or plug in or replace a 3. And everywhere there's an n, we're going to substitute with a 2. So let's take a look at the left side. Each side individually. The left side said x plus y in parentheses, then to the nth power. Plug in, substitute in, x should turn into a 1, y should turn into a 3. Okay, n, we should substitute a 2. And then take a look at this. Let's simplify 1 plus 3 in parentheses to the second power, following the order of operations, meaning we need to do the parentheses first. So 1 plus 3 simplifies to 4. There's still the square, and then 4 squared is 16. Now the right side's up here at the top said x to the nth plus y to the nth. We'll substitute here as well. And we have 1 squared plus 3 squared, which simplifying the exponents first gives us 1 plus 9, which simplifies to 10. Now take a look. We have 16, we have 10. Those are different. That's the end of this process here. Now, why does this work? Why is this enough? Why is this sufficient? The point is, this formula here, we showed one example where this formula is false. So it just can't be trusted in general. It doesn't even work when you substitute in the numbers 1, 3, and 2 for x, y, and n. So maybe it works for some combinations of substituting for the variables, but it doesn't work once. So this formula can't be trusted. It's just not something that's going to work in general. Now, here's the thing. I want to make sense of this phrase that you saw just a moment ago. Don't use the formula in question. So up here in the question is this formula. You don't want to use this in your argument because that would be circular reasoning. So when you have the left side, which right here is 1 plus 3 in parentheses to the second power, that should become 4 squared by the order of operations. Don't turn this into 1 squared plus 3 squared. Turning 1 plus 3 quantity squared into 1 squared plus 3 squared, that's using this formula. Right now we're trying to talk about, is this a valid thing to do in the first place? And in the process of trying to talk about, is this valid to do or not, we don't want to apply that process. That would be circular reasoning. Let's take a look at another one. Is the formula x times quantity y times z equal to xy quantity times xz quantity true or false? Explain. Again, the way this is worded, it's the question does not give away whether this is true or false. This one happens to be false. We need to substitute numbers for each of the variables. Again, we should pick some values that will make everything work out so that the left side and right side will simplify to different numbers. So here's what will work. I picked x is 2, y is 3, z is 4. There's other choices that would work, but let's just go with these ones. So the left side, I copied it down right here. Now we'll substitute 2 times quantity 3 times 4. Now don't take this 2 and start distributing this to the 3 and to the 4. That would be using the formula in question. So instead, simplify using the order of operations. We should do what's in parentheses first, and we'll get 24. On the right side, substitute for x and then y, and then substitute x again with a 2. So everywhere you see an x, we'll get a 2. Looks like this. Sorry for the extra parentheses, but otherwise this might have accidentally looked like 23, but it's x times y here, so it should be 2 times 3 there. We'll focus on what's in parentheses first. So in this outer shell of parentheses, there's 2 times 3 becomes 6, and here 2 times 4 becomes 8, and then we're left with 6 times 8, which is 48. Now take a look. Again, the left side simplified to 24, the right side simplified to a different number, 48. So this is enough. We've seen one example why this formula doesn't work, and so it doesn't work in general. If it doesn't work plugging in 2, 3, and 4 for x, y, and z, maybe it doesn't work for any other combinations. I mean, if it does, okay, but in general, this is just not going to work. Again, please avoid this circular reasoning. It's very tempting to want to take 2 times quantity 3 times 4 and decide to take this 2 and do 2 times 3 and then 2 times 4 like this. But that would be using the formula in question. That would be circular reasoning. The whole point here is that by plugging in and then simplifying by the order of operations, we actually see that we shouldn't trust this formula in the first place. So we don't want to do this thing that applies this formula, that uses this formula, if it's not trustworthy in the first place. So we're seeing here that we need to have a reason to trust this. Turning this into that would be trusting the formula before we even have a reason to trust it. Here's another example. Is the formula root x plus y equal to root x plus root y true or false? Explain. This one's also false. We'll pick some numbers. Now here, it's helpful if you'll notice this root x. It's helpful to pick a number that's a perfect square. Now if you picked x to be 10, okay, but then it's going to be hard to simplify root 10. So here, based on root x and same reasoning for root y, I picked x is 9 and picked y is 16. This happens to be a combination of numbers that really makes this one work out real nice. So the left side, substitute 9 for x, substitute 16 for y, and you have root 9 plus 16. Again, don't distribute the square root sign. That would be applying the formula or using the formula in question. We're not sure whether we should trust this up here or not. We're trying to argue actually in the moment, and we're not even done arguing, but we're trying to argue that we shouldn't trust this process. So let's see why we shouldn't trust this. So simplify using the order of operations, meaning just take care of what's inside the radical here. We have root 25, which simplifies to 5. On the right side, it's root 9 plus root 16, so 3 plus 4, which turns into 7. In the end, the left side was 5, the right side was 7, different numbers. This formula doesn't work in general. It doesn't work to turn this thing into that thing when x is 9 and y is 16, so it doesn't work in general. Okay, so we selected, just as a comment, was kind of already mentioned, but we selected x equals 9 and y equals 16, both perfect squares, to make the right side easier to simplify by hand. The right side was root x plus root y. Also, by selecting x equals 9 and y equals 16, we got real lucky just with these choice of numbers. The left side became root 25, and that's also nice to simplify by hand. Again, don't use the formula in question. If you look at root 9 plus 16 and turn it into root 9 plus root 16, that would be using the formula in question. That is circular reasoning. Okay, so let's step back for a moment. We've looked at 3 examples of showing a formula is false. Let's bring up some comments here. We showed x plus y quantity to the nth equals x to the nth plus y to the nth is false by plugging in numbers. A true formula must be true for all combinations of plugging in numbers. Any combination at all. So a formula being false just once makes a formula false. Never use the formula in question. For example, when looking at this false formula, turning something that looks like x plus y to the nth into x to the nth plus y to the nth, or in reverse, turning x to the nth plus y to the nth into the form x plus y to the nth, that would be trusting this formula. And we shouldn't do that. That's circular reasoning. So instead, for a false formula, simplify the left and right side independently using the order of operations. When you're tempted to use the formula in question, the point is to simplify using the order of operations instead. And we can do this. Because we have plugged in numbers everywhere, there's no more variables. So you can do the arithmetic by order of operations. Do show all your work. If you jump directly from 1 plus 3 quantity squared to 16, this skips this middle step of 4 squared. It's less clear that you use the order of operations. And if the two sides simplify to different numbers, you're done. If not, maybe just pick new numbers to plug in to see if the formula you're talking about really is false.